the last component we're going to look at of a sine wave is called phase shift. So here again in Desmos, I can just type in sine of x. I've already set this up where my x goes from negative 1,000 to 1,000. I put y from negative 3 to 3, and I am in degrees. So phase shift gets a little complicated if you want to like do specific stuff with it, but we don't. We're just going to put plus s in here and see what happens. So you can see this default slider moves it a little bit left and right, depending which way I go. So let's just modify that, maybe negative 500 to 500 by 10s, for instance. So now we can see better when we move it to the right, the wave goes left, and when we move it to the left, the wave goes right, which is a little backwardsy, but it doesn't really matter. That's the point. Phase shift just moves the wave left and right. And if we'd added in period, amplitude, and midline as well, the phase shift would just, whatever the result is, just moving it left and right. So now let's do something more interesting and see why phase shift matters. So what I'm going to do is I'm going to call this F, and then I'm going to write another one called G. G equals sine of x, just our default wave unshifted. So these can either be completely matched up right on top of each other, or they could be completely out of phase, where when the green one is tall, the red one is negative. They both have zeros at the same points, but they're basically mirror images of each other there. So let's now do something and add them together, F plus G. Let's look at that resulting wave looks like. So now we have this purple wave, which adds them up. If the waves are completely in phase, right on top of each other, then they augment each other. The resulting wave from adding them is stronger, because you can see 1 plus 1 on both of these gives us 2. But as we move F here to be out of phase, the purple wave starts decreasing. And in fact, when they are exactly out of phase, you can see the purple wave almost disappears until it does entirely. In this case, the waves are completely canceling each other out, which is a principle that is pretty important if you're looking at sound design or engineering, or electrical engineering. Even if you're looking at noise canceling headphones or something, they can just cancel noise by understanding what wave is coming in and then playing it back exactly out of phase to cancel out the incoming sound. We don't get a lot of use out of this in this class, but it is kind of fun just to see that one specific application.